limit is y goes to negative 2 of 2y plus 4 plus tangent of y plus 2 divided by y squared plus 6y plus 8. The first thing we're going to do is plug in negative 2 in for each of the y. So we'll have 2 times negative 2 plus 4 plus the tangent of negative 2 plus 2 all over a negative 2 squared plus 6 times a negative 2 plus 8. 2 times negative 2 is negative 4 plus 4 plus the tangent of negative 2 plus 2, which is a 0, divided by a negative 2 squared is 4. 6 times a negative 2 is negative 12 plus 8. In the numerator, negative 4 plus 4 is a 0, plus the tangent of 0 is the sine of 0, 0 divided by the cosine of 0, 1. 0 over 1 is a 0, over 4 minus 12, which is a negative 8, plus an 8. 0 plus 0 is 0, over negative 8 plus 8 is 0. We have the 0 over 0 indeterminate form. Since this is resulting due to trig functions together with power functions, we're going to make use of the identity. Limit as theta goes to 0. The sine of theta divided by theta equals to 1. That's happening due to the tangent function in the numerator, but since it's added to other terms, we're going to separate those apart over that common denominator. So we will have limit as y goes to negative 2 of 2y plus 4 divided by y squared plus 6y plus 8, and then added to the tangent of y plus 2 divided by y squared plus 6y plus 8. Now, since the first fraction is 0 over 0 due to power functions, we're going to be able to do a factor cancel method for that. The second fraction is 0 over 0 due to trig together with power functions, so we're going to make use of the identity. But to make use of the identity, we have to turn all non-sine cosine functions into sines and cosines. So we can work with each of these. This first one, we're going to try factor cancel. In the numerator, I can factor out a common factor of a 2, and there's a y plus 2 factor that's making a 0 because y is going to negative 2. In the denominator, we can trinomial factor, and we have y and y. We need two numbers that multiply to be a positive 8 and add to be a positive 6. And therefore, it looks like a positive 2 and a positive 4 will take care of that. They multiply to be an 8 and add to be a positive 6. So, and there's the y plus 2 factor in the denominator that's making the 0 in the denominator. Those y plus 2's can cancel, so we're going to do that. And we no longer have 0 over 0 for that one. So that fraction is ready to go for the limit. Now, for this other fraction, the tangent can be written as sine over cosine, so we're going to do that. Now, by doing so, we've just created a fraction in the numerator, so we're going to need to reciprocate the denominator fraction and multiply it with the numerator fraction. Well, the denominator is not a fraction, but it will be if we put it over 1, so let's go ahead and do that. And we have limit as y goes to negative 2 of 2 over y plus 4 plus the numerator, which I will just rewrite exactly as we see it, times the reciprocal of the denominator, which is going to be 1 divided by y squared plus 6y plus 8. Our next step is then to multiply those two fractions. We're going to leave this first one alone, and we're going to multiply the two fractions to make a single second fraction. Sine of y plus 2 times 1 will give us sine of y plus 2, and it will be over, and we have y squared plus 6y plus 8. All of that is going to multiply the cosine of y plus 2. And so I will write the power function first and then the cosine, as you see here. Now we still have 0 over 0 for this second fraction because we haven't made use of the identity yet. We're going to do the work now to make the identity happen. To make the identity happen, we're going to isolate the sine functions. There's only one of them in this case. It's in the numerator. We're going to isolate it by still keeping it in a numerator. And we're going to take everything else, which is all in a denominator, and make another fraction out of it. And put it in the denominator so that we can now phase match that sine function. Sine of phase y plus 2 in the numerator needs a y plus 2 in the denominator. To compensate for that, we put a y plus 2 in the numerator in the other fraction. We now have the phase match identity for the sine fraction. The other fraction is still 0 over 0 because we have a power function making a 0 here and a power function making a 0 there. And so our next step is to be able to eliminate the 0 over 0 from those, and that's going to be by factor cancel, as we always do for power functions. So this will give us limit as y goes to -2 of 2 over y plus 4, we're just leaving alone. Sine of y plus 2 over y plus 2, we're just leaving alone. And then this other fraction, which is a y plus 2 in the numerator, we're going to trinomial factor that denominator. We need two numbers that multiply to be a positive 8 and add to be a positive 6. Well, we've done this factorization already, and it turned out it was a positive 2 and a positive 4. And then we'll just leave the cosine alone. The cosine of 0 is a 1, so we're never worried about that. It never makes 0 over 0. And y is going to a -2, and we're getting 0 over 0 because of the y plus 2 factors. Let's cancel those out. And at that point, we should no longer have 0 over 0 with that fraction either. So we have 2 over y plus 4 plus the sine of y plus 2 over y plus 2. That's the only fraction left over that has 0 over 0, but because of the identity, that whole fraction is just going to come out to a 1. And then we have 1 over y plus 4 times the cosine of y plus 2. And at this point, we can now run the limit. That phase match sine ratio fraction will be a 1. And we can plug a -2 in for all remaining y's. We should no longer have 0 over 0. So we will have 2 over -2 plus 4 plus 1 times 1 over -2 plus 4 cosine of -2 plus 2. So this gives us 2 over -2 plus 4 is a 2. Plus 1 times anything is that same thing, so we don't need to write that first one. We'll have 1 over -2 plus 4 is 2. Cosine of -2 plus 2, which is a 0. So we have 2 over 2 plus 1 over the cosine of 0 is a 1. So we have 1 over 2 times a 1. This gives us 2 over 2 plus 1 over 2, which is equal to 3 over 2.